Hello and welcome to this S2 chapter 6 video on populations and samples. This is the third video in this chapter, and in this video we're looking at an example. We're trying to put into practice some of the things we learned about in the second video, so in particular things like population parameters, calculating those, listing samples, and in particular trying to work out sampling distributions. So let's look at this question together. We've got a manufacturer of light bulbs, and he sells 60 watts and 100 watt bulbs in the ratio of 3 to 1, meaning he makes 3 times the number of 60 watts as 100 watts. And we're asked to work out the mean and variance of the bulbs in the population, and then to list all the samples of size 3, and then to work out the sampling distribution for the mean of those samples. So here we're talking about the population parameters, the mean and variance of the population, whereas here the mean we're talking about a statistic, the mean of the samples. So the sample distribution is always about the way that the statistic is distributed. So we'll get to these ones in due course. Let's do part A first. It's a bit strange actually in S2, the way it's often easier to work out the population parameters than it is to work out the sampling distributions of statistics. That's not really how it is in the real world, because in the real world actually the reason you do these things is because you can't easily determine the population parameter. But anyway, I suppose it's a good thing to start with so that you know the answer to, so you can sort of see it working in practice, and it's the kind of questions you get asked in the S2 exam, so let's just get on with it. So this first part A, is just the same as an S1 question. We know that the power rating, X, of these bulbs, so let's just do a small x here, could be 60 watts or it could be 100 watts. And we know from these numbers here that the probability that our power rating is equal to 60 watts is 3/4, and the probability that it's 100 watts is 1/4. Just look at the ratio there. To work out the mean, we just do 3/4 of 60 plus 1/4 of 100, which gives us 70. To work out the variance, we just have to do 3/4 of 60 squared plus 1/4 of 100 squared, and then we have to take away the mean we just worked out squared, which gives us, I think, 300. I guess the units would be watts squared, but not to worry, we're not doing physics, so if you don't understand the units there, don't worry. The numbers 70 and 300 is what we care about. So this is just S1, discrete random variables. Hopefully you recognise that. If you don't, it's a bit of an S1 problem. Maybe go back and have a look at that S1 chapter. That's part A. Part B then is where we start doing some S2 stuff. So listing all the possible samples of size 3. So a sample, if you recall, is a list of 3 numbers in this case, because it's size 3. Each of those numbers is distributed in the same way as the original x. So there's a 3/4 chance that x1 could be 60 and a 1/4 chance that x1 could be 100. I suppose it could happen that all 3 of them are all 60. Or it might happen that x1 is 60, x2 is 60, but x3 is 100. Or I suppose it could be that x1 is 60, x2 is 100, but x3 is 60. Notice that they're different, because a different variable is 100 here. I suppose that's the last one. Now, this is sometimes confusing because it looks like those 3 things are the same thing. Each of those samples consists of 2 60 watt bulbs and a 100 watt bulb, but they are technically different because different variables, these different independent random variables here were 100 in each case. I think the thing here is there's more ways of getting 2 60s and 100 than there is getting just 3 60s. It's very similar to when you sort of flip a coin in probability theory, and there's more ways of getting, say, 2 heads and a tail than there is getting 3 heads when you flip a coin 3 times. So we've got to look at all these options. Then you could get the first one 60 and the next 2 are 100. And then you can get the first one's 100, 60, 100. So there's 3 different ways of getting 200s and a 60. And then finally they could all be 100, I guess. Obviously these ones are related, and these ones will be the same result. You get 260, but in a different way. So it's important that you list all the ways. Notice that the number of ways of getting different things is found easily by working out how many choices you've got in each case. Here there's 2 choices, and then how many times you have to pick. So you've got 2 choices here, 2 choices here, and 2 choices here. So you've got 2 times 2 times 2. 2 times 2 times 2 is 8. So we should have 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, so that is our list of samples. C wants us to find the sampling distribution. Okay, so let's think about this then. What are the possible means? Let's do x bar being the mean of the sample. And then next to it, let's write the probability that our mean is equal to x bar. So what means can we get? Well, the mean just here is, well, 60 plus 60 plus 60 divided by 3 is 60. The mean, if you had 102 60s, is 60 plus 60 plus 100 over 3. That's 73.3 occurring. Let's just call it 73. Just here, we can have 260. The mean of that is 86.7, or 86.6 occurring. Let's call it 87. And here, 300s, okay, the mean is 100. So these are different possible statistics we could get for the mean, depending on which sample we get. See, now we know the mean is actually 70, so it seems that you're more likely to get a number close to 70 than away from 70, but these are all the possible options that we could get. What we need to know to make a sample distribution is the probability of getting each of these numbers. Now, be careful here, because the chance of getting 360s is not the same as the chance of getting 300s, because the chance of x1 being 60 is 3/4, whereas the chance of x1 being 100 is 1/4. So it's more likely you'll get some of these options than other options. What's the chance of getting 360s? Well, think about sort of binomial distributions here. Get that first 60 is a 3/4 chance. Getting the next 60 is a 3/4 chance, and getting the next 60 is a 3/4 chance. So that is 3/4 times 3/4 times 3/4, or 3/4 cubed. That's a 27 over 64 chance, right? Beautiful. Just here, we've got 2 60s, so we've got 3/4 times 3/4, and then a chance of getting 100 is just 1/4. So chance of getting that one is that much. Is that like 9/64 there? But there's also a 9/64 chance of getting that way, or a 9/64 chance of getting that way. So there's 3 different ways of doing that. Oh, this looks very familiar. This is a binomial distribution. X1, x2, x3 here. This sample is binomially distributed, should we say. Well, this mean, I think, is binomially distributed. So we've now got 3 times 9/24, sorry, 3 times 9/64. So that's going to give us again 27 over 64. Chances here of getting 60, there's one of those, so 3/4. Getting 100, there's 2 of those, so 1/4 squared, and there's 3 different options. That's going to give us 9/64 overall. And then finally, there's 300s there, each is a 1/4 chance of getting it. So that's going to be 1 over 64. Notice how we're using the fact that each one is independent, so we can just times them together without having to worry about it. The probability of getting that one times probability to get that one times probability to get that one. Remember in the last video we said that each of these x1s, x2, x3s was independent of each of the last ones. So we've used that here. We also said in the last video that x1 was distributed in the same way as the original x. We've used that here by saying that x1 chance of getting 60 is the same as of x being 60, the original distribution. This thing down here is actually your sampling distribution for the mean. It tells you the possible means and the probability of getting those means. If you actually worked out what the mean of the means was, you should find it 70, so that this distribution should allow you to work back to find out what the parameter actually is. It's a bit of a strange question though, because obviously you wouldn't do that because you just directly calculate it. But in sort of like a real world situation, you'd calculate this thing first, and then that will allow you to work out what the population parameter was. That's kind of the point. These are the kind of questions you get asked to do though. Hope that makes sense. The big places people make mistakes is just here where they write down things like 1/8, 3/8, 3/8, and 1/8 rather than looking at the actual probabilities in the question. So Good luck with that.